Now, this is a fairly obscure piece of art, but it's actually a photograph of a terrible fire on the Deepwater horizon. Now, how does a ship look like this when really it's supposed to look like this? How does this happen? And the answer is fairly straightforward. It actually happened in the Gulf of Mexico, where over here is where the big meteor hit. There was a much bigger oil spill some years ago, but it happened to a poor country, so nobody cared. Then the Deepwater Horizon leaked there. And it's an amazing ship. It really is, as a piece of technology, really quite astonishing. It shows that we humans can do wonderful things if we put our minds to it. So it sits up there and floats, and it can survive really big storms. And then they drop down some pipes to the ocean floor. They then build this little mini city down here, and then they keep on going all the way down. And this ship cost over $500 million to build, and it can drop its drilling string down 1.5 kilometres until it hits the ocean floor, and then drop the drilling string down another 9 kilometres, which is taller than Mount Everest. It's amazing technology that we humans can do this sort of stuff. And yeah, so here you are on the top and dropping it down, and here's the little mini city that they have on the ocean floor. And it all goes terribly wrong because we are addicted to oil. This is my four-wheel drive, which I used to have. I've been through 15 of the 17 deserts in Australia. On our biggest trip, we started at Alice Springs, went west for 1,000 kilometres, turned right, went north for 1,000 kilometres, and in that month we didn't see another human being, and we carried 600 litres of petrol, of which we end up with at 40 at the end, and drank 1.5 tonnes of water. This is the time where we have the chemistry lesson. Sally and Eddie were very clear that this was the point where we have to insert the chemistry lesson so you get a better understanding of our whole environmental impact here. So in this chemical here, anything H is a hydrogen atom, and where two lines meet in organic chemistry is always a carbon atom, because carbon is so common you don't even bother putting it down. And this N, of course, stands for nitrogen. You know this stuff. You already know from your basic high school that this chemical is called a pyrrole, and you know that if you get the nitrogen and then you replace it with an arsenic, you get a chemical that's not called a pyrrole, it's got a slightly different name. And here's a scientific paper, Unterstellingte Arsol, the 1-chlordiphenyl, which in plain English means studies on the chemistry of this particular chemical in the Journal of Organometallic Chemistry. Let me tell you, that is essential bedtime reading. I love it. But you get these weird names. I'm like, what on earth do you call chemicals? Like, what if it's got a whole bunch of stuff in it, like magnesium and iron and silicon? What on earth are you going to call it? Luckily, it was found near the town of Cummington, and so glories in the name of Coming Tonight. And you can hear them sing that past the... Oh, now you get it. And you can hear them sing this at the geology department. I feel like coming tonight, coming... Now, really, with this topic of chemical names, you might think I'm being a bit of an aluminium silicon oxide hydroxide. So I'm doing just a little bit too much Sansin. So with regard to this topic of chemical names, I'll just simply 1-deoxy-D-galactocol and move right along, getting back to our old friend oil, or as they call it in the trade, buried sunshine. The stuff that you get from the petrol bowser is indeed buried sunshine. When you fill up your car with 70 litres of petrol, to make that 70 litres of petrol took 1,500 tonnes of vegetation, which had to grow on over a square kilometre of land, and which took millions of years to cook in the ground. Every time you boil, you fill up with 70 litres of fuel. Or in my case, 600 to get across the couple of deserts, or normally the onboard tanks that take 300. Now, at the moment, it seems that we are roughly halfway through the red asterisk, blue asterisk crude oil. Now, red asterisk means easily available. If easily available means that you get a $500 million ship and you send out in the Gulf of Mexico and you've got this incredible technology. In today's so-called what passes for economics, we call this easily available. And then you've got the blue asterisk, and blue asterisk means sweet. It means it doesn't have any sulfur in it. We can make oil out of this wooden floor, the carpet, the chairs, your clothes, my shirts, which would be a crime against nature. But we can make oil out of anything. It's just really expensive. If you get sweet crude oil, it's cheaper, so there's bigger profits down the other line. And the thing that I like about oil is not that we burn it. I hate that we burn it. Because in oil, there are all these amazing long chain molecules that are just so strange that we've never seen. And we stumble across these things in oil, and then instead of saying, wow, let's make a plastic, there are plastics that you can make a fry pan out of that will withstand the heat of a gas flame. And instead of preserving these and just using them in small quantities as a raw material so that they survive for our great-grandchildren and their great-grandchildren and so on, we get these weird chemicals and we break them down into chains of carbons, 8 to 12 carbon atoms long when they're liquid, and we burn them. We destroy all that information. When I first started four-wheel driving about 20 years ago, the only cable that you could have to pull yourself out of trouble if you got bogged with the winch was a steel cable. Now you can get special Kevlar cables which are weight for weight stronger than steel and size for size stronger than steel. Because we found this chemical accidentally in oil. But things are changing. And a really good example of how it changes is in the newspapers. Now there's a couple of newspapers in Australia. There's just the ordinary tabloids. They've got a reading age of 10. There's the Herald and the Age and the Australian, which has a reading age of 12. And then there's Financial Review, which has a reading age of 25. And in the Financial Review, they tend not to talk crap. They just talk it how it is because they're dealing with the money market and things, lies, mistruths just pop up really quickly. And on the front page, on the 5th of August this year, there's this nice, cute little article here. And there you can see a picture of a house and some people on the sand. And you look a little bit more closely, you can see, whoa, some sandbags there. And then it says, sea change sinks coastal land values. In fact, inside on page 6, it says it submerges coastal land values. And quoting, it says the land values have been slashed by 50% thanks to climate change affecting coastal property. 50% has already happened there. What we're talking about here is global warming, which, according to all the scientific evidence, is real, is caused by humans, and is happening now, and is going to be bad. As one little example of where it's happening in the world, and there are hundreds upon hundreds, just look at the Arctic ice melting. Now, originally they thought that over this 2-century span from 1900 to 2100, the ice would drop, so here's the area of 8 million square kilometres of ice. It would have dropped down to a couple of million by about 2100. And then suddenly, beginning in the 50s and 60s, it began to just drop down enormously quickly. And the way to compare it, your benchmark, is your sea ice minimum, which happens in the hottest time of the year, which is September, October, and the results have just come in. So this is the ice in 79 compared with 2005 when it's minimum, at the hottest, a month or a couple of months after the longest day of the year. And if you in this animation, it's a bit like a guy with a yo-yo walking down a hill. The yo-yo goes up, it goes down, it goes up, it goes down, but overall, the trend is downwards. Relentlessly, the trend is downwards. But year to year, you can't tell anything. 3 years, you can't tell anything. But if you do it over half a century, then you can see the trend. And here you can see the difference between 79 and 2005. And the IPCC, the Intergovernmental Panel on Climate Change, has, until now, not included positive feedback loops. Now, what's a positive feedback loop? If I was to really mean to Damien and all his mates there, I'd climb up there in front of the speaker and put my microphone in front of the speaker and suddenly get louder and louder and louder. Or a positive feedback loop is when you put a pen on the edge of a table and you push it, you push it, you push it, and then once it gets too far, it tips over. That's a positive feedback loop. Or in the case of ice, white ice reflects 90% of the heat that lands on it. But it turns into black water, which absorbs 90% of the heat. So once it's absorbed some of the heat, it then tries to melt the ice, which then goes around and around and around. And at some stage, and we don't know whether we've got there yet or not, you run into this positive feedback loop where if you do nothing, it just keeps on going by itself. And we've got two ways of measuring the ice: surface area and thickness. Now, thanks to recently declassified US Navy and Soviet data, we've found that over the last half century, the ice thickness has shrunk from 3.5 metres, which is sort of, I don't know, up to about there, to about there. From 3.5 metres to 1.5 metres, averaged all over, because this is military data, because the submarines had to know exactly how thick the ice was everywhere, so they could just punch through it and let off a whole bunch of nuclear weapons to wipe out humanity. So it was a really important and very worthy job. And as a result, they mapped it really well, because the military has a relatively infinite budget. So that's how we know the thickness of the ice from recently declassified military data. The surface area we get from satellites, which have not been running for so long, only since 1979. And this is the curve for the surface area of the ice, from 8 million square kilometres, bouncing up and down. And then suddenly in 2007, it went down to about 4 million. And people were saying, is this a tipping point? We don't know. I mean, is it? Is it not? And the thing was that was actually one of the coldest years on record for the sun, because the sun is not a constant candle. Over an 11, 13-year cycle, the sun varies by 1 part in 1,000, and now it's on its way up again. And then just recently, in the last couple of weeks, we got this last bit of data through, showing that in 2007, it went down to 2008, 2009, and now it's down again in 2010. We have to wait another year to see what happens in 2011. Will it come back up? Will it go down? We have no idea. We're just watching it. The thing about tipping points is that you do not know when you've reached the tipping point. You only know after it's already happened, after you've got the feedback, after the pen is tipped off the table, after it's too late. Only then do you know with the tipping point. And with regard to positive feedback loops, what I've been hearing from my colleagues in the IPCC who have never incorporated positive feedback loops in so far, and have been deliberately conservative and kept the limit down of ocean rise to about 1 metre, they're saying to me privately behind the scenes that when they release this in 2017, we're looking at 7 metres above sea level, which is probably about somewhere up there, because we're about 1 metre above sea level here. And the wealthy and the cities in Australia can do something about this, because they've got a large tax base in a relatively small area, and do the thing that they did in Holland and just build these enormous seawalls. Country areas do not have the tax base. That's all there is to it. Australia does not have the tax base. We're the opposite of Holland. We have a huge surface area and we have a very small population.